Welcome back. So after we read the problem 3 times, I actually prepared the drawing for you, which is here. Okay. So this is a square cardboard, and the length of each side is 12 inches. Okay. And then I started to cut the squares from each corner. Okay. And after that, you see, okay, so I can give you some basic ideas about how this thing works. And you see, guys, if I cut those squares, okay, and you will see that when I fold it, I'm gonna have a open box. Well, in fact, let me try to see if I have a scissor. Okay, here we go. We got a scissor, and then now I started to cut. Okay, so one square. Let's go. Okay, and then the second corner square is gone. Okay, and then let's see. Third quarter square is gone. Last one. Here we go. So you see, guys, I already cut the 4 corner squares, and then when I fold it, do you agree that this is the open top box, right? So that's a problem. And then the question is, how should I cut the corner squares such that this box is gonna have its maximum volume, right? So that's the problem. And as you can see that, guys, different cutting about the size of the corner squares, it will give you different volume. Okay, so after we draw this picture, right, and you can do that, and then we're starting to look at the unknowns. What is unknown, guys? And if you look at this, do you agree that actually the unknown is, what's the length of this each corner square, right? Because this part we don't know. We don't know how much we should cut. Maybe I should cut more, right? And then the volume gonna be bigger. We don't know. So that's the unknown. And what I can do is I can set the length of the corner square as x. Okay. So maybe let me label that. So you can see that this part is x. This part is x, this part is x, this is x, 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 x. Okay, so we'll put it here. And you see, guys, right now we set up the unknown, which is the length of the corner squares, as x. Now we're starting to move on step 4. We're trying to construct a function with this unknown. Okay, so what's the function we should build? Well, you look at what do we want. We want to figure out the largest volume, right? So the function is going to be, let me use a different marker. it's gonna be the volume function with respect to this unknown x. But how do we calculate the volume of this open box? And again, guys, if you look at this part clearly, do you agree that to form this open box and then to calculate volume, I need to know the area of this base and then multiply its height, right? And you see, if we fold it up, we put it back, realize that actually the base of this open box is also square, right? And we can also easily to calculate the length of this base square. And since this part from here to here, which is 12 inches, and then so do you agree that the length for the base square, which is 12 minus 1x minus not the x, right? So the length for each part, it's gonna be 12 minus 2x. Okay, so the volume is gonna be 12 minus 2x squared. That is the area of the base square, okay, times the height. What is height? As you can see, if you fold it up, do you see the height, which is the unknown length, right? X. Okay. So with this, we build our function. Okay, and then we start to take care of this function with all the knowledge we were to learn in the beginning of this chapter. Okay, and we need to figure out what is the critical point, and then we can solve this problem. Okay, so let's try to see if we can use this small area here. So if we take the derivative of this, you see that you're going to use the product rule, right? So you're going to be 2 times 12 minus 2x times negative 2 times x, right? And then plus 12 minus 2x squared, because derivative of x is 1. Okay. And now if we reorganize this part, we're going to have is negative 4x times 12 minus 2x plus 12 minus 2x squared. I hope you can still see this. Okay, cool. And then if I do a reorganize, you see I can factor 12 minus 2x out. It's going to be negative 4x plus 12 minus 2x, then multiply 12 minus 2x. Okay, so if I simplify this, then I'm going to give us is negative 6x plus 12 times 12 minus 2x. Okay, 12 minus 2x. All right, and maybe let's use another board. Okay, those are the 5 steps. We already on step 5. Okay, read, 3 times sure. Draw a picture, draw that. In fact, I cut it. Figure out the unknown variable. Find it. That's the length of the corner square. Construct function. Area, volume of the open box. Find the critical points and extreme values. That's what we're doing. Okay. So let me have more space here. Okay, let's see if this is now. So the derivative function, Vx, as we see that, it's a 6x minus 12 times 12 minus 2x. Okay. That's right. Let's see. So that's excuse me. That's negative 6x plus 12. Okay. It's negative 6. negative 6x plus 12. Okay. And if we solve this, set it equals 0, you're going to see that if we set we prime x equals 0, we can solve that x equals 2 or x equals 6. Okay. And then we can, those are the two critical points. In fact, guys, as you can see from here, we already can get rid of one. Why? Because think about this. The length of the original cardboard, square cardboard, which is 12 inches, right? And if you cut the corner square with a width which is 6 inches, in fact, there is nothing left, right? Because basically it's kind of like you are cutting something like this, right? So if you cut this square, cut this square, cut this square, cut this square, there is nothing left. So it cannot be a open box. So okay, so but we can always verify because the volume of x, which is 12 minus 2x squared times x, if you plug 6 in, you're gonna see it's a 0. There's no volume there. And if you're gonna plug 2 there, which is 12 minus 2 times 2 squared times 2, it's gonna give you, this is 8 square 64, 128 inch cube, right? So that's the volume. And then the dimension, as you can see that the height of that open box was going to be 2 inches. And then the weight of the base square is going to be 8 inch. Okay, so like this, right? So the base here is 8 inches, 8 inches, and then the height, which is 2 inches. Okay, so we finished the problem. Okay, so again, I hope you you can follow this, and every application problem is different or it's the same. Okay, it's different because the objective function is different, and then the unknown is different, hidden information is different. It is the same because if you go over with those 5 steps, they basically follow the same procedure. Okay, and I hope you enjoy this video. Thank you.